half the base, so it should be 4.5.
Teachers, at this time, could we please have At this time, could we please have Matt Mrs. to the lobby for photos? Matt Mrs. for club photos.
Notice as soon as I started recording my YouTube video, that's when she came on. It is okay. So, your favorite section so far, if I had to guess, in geometry, was when we did rotations, reflections, and translations, because those are pretty easy. They're easy to spot, they're easy to understand. So you'll be happy to know that this is very similar to that. We're going to do something today that is another transformation. But with a transformation, the shape had to stay the same size.
At this time, can we have Skills USA Engineering to the gym for club pictures? Skills USA Engineering, thank you.
This is why I don't like it, because this happens right here, and this gets on my nerves, because I'm standing up here spewing out my words of wisdom, and you've done tuned me out. This is why I'm mad at you, and no, I'm not doing it anymore. Don't ask me any more questions. I will call you out in my YouTube video, full name, everything. Okay, so a transformation where we change sizes is like a dilation. What part of your body do you get dilated? Your eyes. So you already know what happens with a dilation. What happens to your pupil? It gets really big. So we're going to have a dilation, but ours can get larger or smaller. So if it gets larger, it's called an enlargement. If your eye gets smaller, we would call it a reduction. So we're either enlarging the shape or we're reducing the shape. But of course, we're doing it all, the key word of the whole chapter, proportionally. We're doing it all proportionally. Okay, when we do things proportionally, what are we able to calculate? We've calculated it in almost every single section so far. The scale factor. So the scale factor of a dilation is the ratio of a length on the image to a corresponding length on the pre-image. Okay, all that means is if you get a big number going from A to B, then obviously you got larger, so it was an enlargement. If you get a small number for your scale factor going from A to B, then obviously your shape was reduced. So if you get a fraction less than 1, your shape was reduced. You get a number bigger than 1, your shape was enlarged. Okay, so all we have to do, and there are only 3 examples today, all we have to do is determine whether figure A to B is an enlargement or a reduction. So is this an enlargement or a reduction from A to B? A to B. A is the beginning. It's a reduction. That's the hardest part, is who came first. So A came first, then we went to B. B is a bit smaller, so it is a reduction. And then the second hardest part of this section is following all the directions. So it also says we have to find the scale factor of the dilation. We have to find the scale factor. To find the scale factor, we need to compare all the sides. So I need to compare this side to this side. And that one's actually really easy because we can count it. We can count from here up to here. How many blocks did it take up? 4. So this one was 4. How many blocks did this side take up? 2. So from A to B, if we put B on top because he's new, 2 over 4, that's 1/2. So we did one side, but this is a triangle. We're going to have to do the other 2 sides as well. So it's easy to do the bottom. How far across is it on the bottom of A?
Wait, for the 2/4, you wouldn't put a negative?
No. I'm just counting to see how long the sides are. That's all. I know what you're wanting to do. Just count how long the sides are. How long is the bottom of this shape? Count the blocks. 1, 2, 3, 4, 5, 6. I got 6 as well. So I got 6. How long is that side of B? What did you get? Someone can count today. 3. Okay, what does 3 over 6 reduce to? Okay, so far so good. But the bummer is we get to this last side and it's not an easy count. It's not an easy count. So we can either pray Miss Compton doesn't notice we only did 2 of the 3 sides, or we can try to make a way for this to be easy. So we could do the whole distance formula between these 2 points to see how long that is, and between these 2 points to see how long that is. But that would require us all to remember the distance formula, and we don't all remember that. So if that's what you want to do, that's the really mathy way to do it. I am a lazy person, so I'm going to do it a different way. But if you want to do the distance formula between the 2 endpoints on that side, and between these 2 endpoints, and make sure it's still 1/2, that will always work. Okay, so the lazy man doesn't want to use the distance formula. The lazy man wishes he could still just count and figure it out. So you can count the distance formula. I think I've showed you before, but now would be the time to understand it. So if I were trying to go from this point to this point, all I need to do is count how many up and how many over. So I go up 1, 2, 3, 4. So I need to know whatever 4 squared is. I go over 1, 2, 3, 4, 5, 6. So I need to know whatever 6 squared is. Again, instead of actually using the distance formula, I can figure out what numbers went into the distance formula by counting. I went up 1, 2, 3, 4. I went over 1, 2, 3, 4, 5, 6. Then I don't have to do x2 minus x1 squared, y2 minus y1 squared. I don't have to do anything like that. I'm just counting. Okay, that is 16 plus 36. What is the square root of 12? 52. I don't know that. I don't know what that is, but I'm going to put it in the denominator, because that's what I counted. So I've got to go back and do the exact same thing with the smaller triangle. So I'm going to count from here all the way to here. So I went up 1, 2. So that's 2 squared. I went over 1, 2, 3. And that's 3 squared. 4 plus 9, which is 13. So you get square root of 13 over square root of 52. And I've done something wrong. I hate teaching math first period. I told Derek this morning when he started asking me questions before I was not ready to ask questions. Did not do math this morning. Yeah, you still get 1/2. When you type that in your calculator, you still get 1/2. Okay. Let's face it. Again, Ms. Compton is admitting it is a little early in the morning to be wanting this from anyone. So if Junior just wants to show me that he understood he counted up 1, 2, 3, 4, and also up, then up 1, 2, that's a ratio of 1/2. He went over 1, 2, 3, 4, 5, 6. He went over 1, 2, 3. That's a ratio of 1/2. That's all I really need from Junior. Oh, Lord help us. So really what you're praying for is not a triangle. You really wish you had something like example B. Look at example B. Why is B easier than A? You can just count. We're not going to have to do that fake distance formula I just did. We're not going to have to do anything. So all we have to do is count. I would love for someone from Sam Samuel to help me count on the bottom. How long on the bottom side? I see the 2 for the tiny one. What's the one for the other one, Sam? 6. So 2 over 6, which is 1/3. Great. So we've got that side. This side was 6. The tinier side was 2. 2 over 6, 1/3. We got to count over here on the right. I'll count that one. That's 1, 3, 1 over 3. Hey, that's also 1/3. Okay, but Miss Compton's purposely done something wrong. Can someone tell me what Miss Compton's done wrong? Okay, let's go back to the beginning of the directions. It says determine whether from figure A to B is an enlargement or a reduction. Is an enlargement or a reduction in this case? A to B. An enlargement. So should I be getting this fraction? No. I need to flip my numbers. It should be 6 over 2 which is 3 over 1, which is just 3, because with an enlargement we want a number bigger than 1. And then we also want 3 over 1 from the right side, which is still just 3. Again, how do you know, Miss Compton? Well, first of all, an enlargement sounds like it should be a bigger number. And 2, notice every single time, if A is our first image, I always put A, whatever we count from A, I always put it in the denominator. Every single time I'm putting my value from A in the denominator. Okay, if I count this side, I also get 3 over 1, which is 3. And then I need to count the top, but it is a rectangle, so it's going to be 6 over 2 still, which is still 3 over 1, which is still 3. Now, if Sam just wants to calculate the top and one side and explain to me in words on his paper that he understands the rectangle is going to have the other sides the same, that's fine. I understand that I did some unnecessary math. Okay, are there any questions on A or B? Okay, so we're going to step it up one tiny notch. This time, in all the others, we were basically told they're already similar. Just figure out, is it an enlargement or a reduction, and then figure out the scale factor. In example 3, we need to prove that they're similar. We're not told for sure. They look similar, but we're not positive. So we need to verify that these are similar. So it says, below is the figure in its dilated image. Verify that the dilation is a similarity transformation. And then it says, use the coordinate grid to find the lengths of the vertices of the vertical segments MO, there's an O over here, DG, and the horizontal segments MN, oh, there's MO. There should be an N then. MN and DF. So we've got to prove that it really is a similarity transformation. Guess what? Nothing changes. I'm still just going to count. So how long is MN? That's what I need to know. And I guess I should start at the beginning. Which one came first? Who's the original? Is MNO or DFG? Okay, so is this an enlargement or a reduction? It is a reduction, so I'm hoping to get a fraction. That's why I figured that out first. I better get a fraction. So how long was MN? 12. And then how long is DF? And that reduces to 1/3. So we're hoping when we compare the other sides, we continue to get 1/3. So let's see, I got to figure out how long MO is. I got to figure out how long DG is. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 9. Perfect. That also reduces to 1/3. So far, so good. Okay, so I'm going to confirm with my brain that I agree with the statement I'm about to make before I get myself in trouble. Oh, perfect
At this
timing.
time, can we have Quill and Scroll and Skills USA TV and film for club pictures in the gym? Thank you.
Okay, so we can argue either two things. We can spin this two ways. Either Ayana can figure out ON and GF and argue that all the sides are similar, so she's arguing SSS. Or she could be a smarty pants and argue a different one of the three. Which one could she argue instead? Because she's lazy and she doesn't want to calculate that third side. She can argue side angle side because it looks like they've got a right angle right there. So she could just say side angle side. Now, would I be more impressed for her to prove that that's a right angle? Yeah. Would I be even more impressed if she actually calculated ON and GF to figure out for real if they're similar or not? Of course. But she figured out the scale factor. She's proving they are similar using one of the three we talked about proving with similarity. She's done everything I want from her. Are there any questions about this? Okay, well then your worksheet's on the back. Either work on you either have 7.4, 7.5, or 7.6. Lord knows you got a worksheet to work on somewhere.